In this video, we will focus on second fundamental theorem of calculus. So in second fundamental theorem of calculus, let's say, let fx be continuous on closed interval a and b if fx is the integration from a to gx for the function of ft with respect to t, then f prime x means that we differentiate the function is equals to differentiation of the integral. Or we can straightforward substitute the gx into the function of ft and then multiply with g prime x, means that we differentiate the gx. So we substitute gx into the function and then we differentiate the function and we multiply with the differentiation of the function of gx. Let's look at example 1. Let's say fx is equals to integration from 0 to 2x squared for the function of 1 minus 3t squared with respect to t. Use the second fundamental theorem of calculus to find f prime x. So we all know that f prime x is equals to substitute the function of gx into the function of fx and then differentiate the gx. So based on this function, based on this integral, here is our gx. So we will substitute into this function. So from here, I will have 1 minus 3. For t, we substitute with 2x squared. So here is 2x squared. And then here is 3 squared, t squared. So here we have power of 2. And then we differentiate the function of gx. So here we have 4x. So substitute the function into ft, substitute the function of gx into f, and then differentiate the function gx. So we try to simplify. So 1 minus 3. So 2 power of 2 is 4. X squared power of 2 is x power of 4. And then multiply with 4x. So 1 minus, here we have 3 times 4, 12x power of 4 times 4x. So finally, our function will be 1 times 4x, 4x, minus 12 times 4 is 48, x power of 5. So here is our function. Then B, find f prime x, f prime 1. So means that we need to substitute the value of 1 into the function of f prime x. So here we have 4 times 1 minus 48 times 1 power of 5. So here is 4 minus 48. From here we should get negative 44. So here is the answer for B. Now we move on to example 2. Let fx be this integral. Use the second fundamental theorem of calculus to find f prime x. Again, we need to find f prime x. So A, f prime x is equals to f, substitute the function of gx, and then differentiate the function. So here is our gx. We will substitute into this function. So means that from here, we should have 2 over 1 plus t. We will substitute with sine x. So it's sine x squared. So this one, we substitute the gx and then differentiate the gx. So our gx is sine x. Differentiate sine x, we should get cos x. So finally, I try to simplify. 2 times cos x, 2 cos x, over 1 plus sine squared x. So this is the answer for A. Then B, f prime 0, means that I need to substitute the value of 0. So here we should have 2 cos 0 over 1 plus sine squared 0. So as we all know, cos 0 is 1. So 2 times 1 over 1 plus sine 0 is 0. So here is 0 squared. So 2 over 1, and the answer is equals to 2. So the important part here is we try to substitute this gx into the function of fx, substitute the function, and then we need to differentiate the gx. So it means that f gx multiply with g prime x.